Okay, so in this video we're going to have a look at coordinate geometry. Now this topic really does extend from what we looked at in the GCSE topics, where we were having a look at coordinate geometry with straight line graphs and perpendicular lines. So do make sure that you've had a look at all of those videos, you're pretty keyed up on those bits of the topic. Okay, I'll link all of those in the description, but this is really going to just depend on sort of an extension from those topics. So there will be some assumed knowledge in this, so if at any point you're not sure on anything that I'm sort of talking about in this, then do go back and have a look at those videos in the description, primarily the ones on perpendicular lines, okay, which I'll make sure is right at the top of the description there for you to find. What we're going to have a look at throughout this video is we're going to have a look at some of the skills and fundamentals behind straight line graphs and some of these questions, and then we're going to have a look at some exam style questions. So the question that's on the screen is the kind of question that we're going to build up to. We're going to have a look at all different types of questions like this, where we've got a sort of visual of the question and some of the sort of wording behind that and how we're going to approach these sorts of questions. Okay, so this is the type of question we're going to build up to, but we're going to start on having a look at some of the fundamentals and just making sure that we're sort of keyed up on those before we have a look at these questions. So we're going to have a look at that one now, and here it is. Okay, so we're going to start by having a look at these types of questions here. So do make sure you grab a piece of paper, grab a pen and make some notes. And we're going to kick off with this type of question. So it says here, find the equation of the line that passes through the point 0, -8 and is perpendicular to this line here. Okay, so I'm just going to highlight these because this line here is not in our usual format, okay? So throughout all these questions, I am going to be using y equals mx plus c as my formula. I'm not going to bother using any other formulas. I know that there are two that you can use, and you may have been taught the two, but y equals mx plus c is what we were using at GCSE, and there's no real reason for us to actually change that. Y equals mx plus c is always going to work for us in all these different types of questions. So I always just like to stick with using the one that we've used for the most amount of time, rather than learning a new formula that isn't really necessary, but it's completely up to you, and you may choose to use your other formula there if you would like to, okay, but I'm going to stick with y equals mx plus c. So for this one here, it says find the equation of the line that passes through that point and is perpendicular to this one. Now, just like at GCSE here, we just need to get this into the form y equals mx plus c. So in order to do that, I need to move the 3x and I need to move this -11 over to the other side, and that would leave us with 8y that's going to be equal to, I'm going to put the x piece first, when we minus that over, it'll be minus 3x, and when we add the 11 over, that's going to be plus 11. There we go, so just minus the 3x over and add the 11 over, and I've done that in one step there. Now obviously we need this to be y equals, at the moment it's 8y equals, so we need to divide everything by 8. And if we divide everything by 8, we get y is going to be equal to, and rather than putting it all over 8, I'm going to put each individual piece over 8. So the -3 will have -3 over 8 x, and then plus 11 over 8 as well, not over 3 there we go. So now it's y equals, we can actually read the gradient from our line, and the gradient of that line at the moment is -3 over 8. Now it says here that that line is perpendicular to the one that we're looking for. So if the gradient that we're looking at the moment, and again do make sure you check out that video I mentioned on perpendicular lines if you're unsure on this little bit, if the gradient at the moment is -3 over 8, our perpendicular gradient, which I'll write as MP, is going to be positive, and then the reciprocal there, 8 over 3. Okay, so doing our negative reciprocal, changing the sign and flipping over our fraction to get our reciprocal. So there we go, we've got our gradient of our line that we're looking for is 8 over 3. Now this line, it says here, passes through the point 0, -8. So all we need to do is put all of these points into y equals mx plus c, and then we will be able to get our equation. So at the moment we have it's y equals 8 over 3 is our gradient, so 8 over 3 x plus c, and then we just need to sub our coordinate in there, and we have an x and a y coordinate given to us just there. Now, this is quite a unique one because it's an x coordinate of 0, it's actually giving us our y coordinate for us. But let's just have a look at making sure that we can sub that in. If we put y in, we get -8 is going to be equal to 8/3 multiplied by the x coordinate, which is 0, plus c. Now 8/3 times 0 is 0, so -8 just equals c in this case. Obviously we'd have to solve it a little bit if it didn't equal 0. So we have our value of c, and we can just plug that straight into our line equation in place of the c just there. So our final equation here is going to be y equals 8/3 x, there we go, minus 8, and there's the equation of our line. Now sometimes it might ask us to write this in a different form. It might ask us to write it so that we have an integer in front of the x value there. We're going to have a look at those questions as we go through as well, but this particular question just wants us to find the equation of the line, and there it is, y equals 8/3 x minus 8. If it did ask you to write it in a different form, just imagine it doesn't want to have a fractional number in front of x there, we could multiply everything by 3 to remove the fraction there. But as I said, we'll have a look at some of those questions as we move on. But there we go, that's the general idea about what we're going to have a look at to start with, finding the equation of a perpendicular line, and just obviously bearing in mind that sometimes the equations given to us are not going to be in the form y equals mx plus c and allow us to find the gradient straight away. But there we go, let's have a look at another question. Okay, so this question here is very similar. It says find the equation of the line that passes through the point -1, -3 and is perpendicular to this line, 4x plus 7y minus 35 equals 0. So again, we need to get this into the form y equals mx plus c, and again, we're going to sub this coordinate in once we've got our appropriate gradient. So if we have a look at getting this done then, if we rearrange this equation, let's have a look, we want to get rid of the 4x and get rid of the negative 35 to start with. So in a similar fashion, we've got 7y is going to equal, and if we're going to minus the 4x over, which we're going to keep at the start again, and add the 35 over, and there we go. Now in this case we've got 7y, so we need to divide everything by 7, and if we do so, we get y equals, and that's going to be negative 4 over 7x, plus, and 35 divided by 7 is 5, so we get a whole number there for that one. So there's the equation of our line, y equals minus 4 over 7x plus 5, and again now we can read our gradient of this line, so it's negative 4 over 7. So if our gradient is negative 4 over 7, then our perpendicular gradient again is going to become positive, and we'll get our reciprocal there as 7 over 4. And again, I'm going to leave it as a fraction. You could convert these into decimals, but I just find on the whole it's much easier just to leave it as a fraction and avoid having to do any conversions there. But as obviously you're doing this on a calculator anyway, it's absolutely fine if you do want to write it as a decimal. So if we plug that into the equation of a line, then we know it's going to be y equals 7 over 4 x plus c. And in this circumstance here, we haven't got a 0 in our x coordinate this time, so we're definitely going to have to sub all our pieces in. So we've got y is going to be minus 3, so we'll put that in place of the y. So minus 3 is going to be equal to 7/4 multiplied by the x coordinate, which in this case is negative 2. And then we're going to add c. There we go. So we just need to tidy up this little bit here. We just need to figure out what 7/4 times negative 2 is. And again, we can do that on the calculator, or you can just write it as a fraction again. But negative 2, and if I do it on the calculator, let's see what we get. We get negative 2 times 7 over 4. And I would just write it as negative 14 over 4, just multiplying the numerator there. But let's see what our calculator brings out. There we go, it simplifies it for us. So we get minus 7 over 2, or minus 3.5. Now for the sake of just making it a little bit easier looking at the numbers, we may as well write it as a decimal here. So we get minus 3 equals, and I could write it as minus 7 over 2, but I'll just write it as minus 3.5. There we go, plus c. Now what we need to do is isolate the c, so make sure we can find out what c is. So we're going to add 3.5 to both sides. So if we add this 3.5, there we go, and we'll add that over to the minus 3. And that gives us our value of c there, negative 3, add 3.5, gives us positive 1/2 or 0.5. So our value of c there, we get c equals 0.5. And again, we're just going to plug that back into our line equation, so sticking that back up just in there. So for our final equation here, we get y equals, and one thing I don't really like to do is to mix together fractions and decimals in my line equation. As you can see, I've got 7 over 4 as my gradient, and I've got 0.5 as my value of c. Now it's not wrong to mix them together, I just like to keep it all uniform, and if I've got fractions in there I keep it as fractions. So I'm going to write it as 7 over 4 x plus, and I'm going to write that as a half rather than 0.5. Okay, absolutely nothing wrong with mixing them together, but it's just very rare that you'll see it written like that, and I like to keep it the way that I'd normally see it. So there we go, y equals 7 over 4x plus a half. So very similar to a lot of the skills that we've used at GCSE, but really key skills for obviously moving through to those exam style questions. So obviously just be careful, you get your line equation in the form y equals mx plus c, then you can do your negative reciprocal for the gradient when it's talking about perpendicular lines, And then we can obviously plug that into our line equation and figure out our value of c, our y-intercept there, and ultimately write our line equation. So here's a couple of questions for you to have a go at. Here they are. So there's two questions here, both very similar to the ones that we've just gone over, looking at perpendicular lines. So pause the video there, have a go at these two, and we'll go over the answers in a sec. Okay, so for the first one, now getting our equation here into the form y equals mx plus c to start with. So, bit weird because we have a minus 6y. So it doesn't really matter how you do this. If you do move the other pieces to the right, you'll have negative 6y equals, and you get minus 4x plus or minus 7 when we take it over to the other side. Now we need to divide by negative 6, obviously just being careful there because it was minus 6 in front of the y. There is a little other way that you could do this. You could actually just add the 6y to the other side and divide by positive 6. You'll still get the same answer, but up to you however you did that. So if we divide by negative 6, we get y equals, and then it's negative 4 divided by negative 6, and we can actually just do that on the calculator. You could actually simplify that if you want, but negative 4 divided by negative 6 is positive 2/3. So we get positive 2/3 x, and then negative 7 divided by negative 6 is going to be positive 7/6. There we go, so little elements in there that might have thrown you from the start. Obviously having that 7/6 there is a little bit different, and obviously we've got a positive gradient going in there that's been simplified as well. Obviously just got to be careful with that negative in front of the y there. We had negative 6. So there we go, we've got our gradient. The gradient is 2/3, so our perpendicular gradient, let's just highlight that. So our perpendicular gradient, or MP, is going to be negative 3/2. And there we go, we've got our negative gradient there. Obviously if you didn't simplify it, you might have an unsimplified fraction there. You might have 6/4, or 4, sorry, it'd be 6/4 once we flipped it, but you might have had 4/6 to start with and got negative 6/4. So just always do have a look to simplify those fractions as we're going along. Okay, so plugging that in then, we've got y equals minus 3/2 x plus c. And then we've got our coordinate up there that we need to substitute in. So we have 3, 4. So y is 4, so we have 4 that's going to be equal to negative 3/2 multiplied by the 3, the x coordinate there, plus c. Now 3 times negative 3/2, and again we'll just do it on the calculator, becomes negative 9/2. So we have 4 equals negative 9/2, which is minus 4.5, plus c. And if we add the 4.5 over to the other side, we get 8.5 as our value of c. So there we go, 8.5 equals c. And again, we just need to plug that into our line equation, which we've got just here. So as our final answer here, we're going to have y equals, and again, you don't have to mix them together here, but I'm going to have minus 1.5 for the 3/2 x plus 8.5. And again, if you did leave them as fractions, you could have minus 3/2x, and then you could have your value of 8.5 as negative 9/2. So you could have it written in two different ways. So just bearing in mind that you could actually have that as well. You could have y equals, if I can just about fit this in, minus 3/2x. Sorry, not 9/2, it'll be 16, 17/2. Yeah, 9/2 plus the 4 would give us, 17/2. So negative 3/2x plus 17/2. You could have it like that as well, okay? So you could have either of those answers. I'm going to get rid of that fractional one there. I'm just going to keep my answer as the decimal form. So y equals minus 1.5x plus 8.5. On to our next one. Let's have a look again. We have our equation of our line there, and we have the coordinate 5 minus 5 this time. So following the same process, let's get it y equals. So if we add the 2x over and add the 15 over, we get 3y equals 2x plus 15. There we go. And dividing by 3, we get y equals 2/3 x plus 5. There we go. So our gradient there is 2/3, the same as what we had before. And then we're going to flip that over. So our negative reciprocal here is going to be minus 3/2. There we go. And we just need to plug that into our formula again. So we've got minus 3/2. So we're going to have y equals minus 3/2 x plus c. And again, we need to sub our coordinates in there, 5 minus 5. So we're going to have minus 5 as our value of y, and that's going to equal minus 3 over 2 multiplied by the positive 5, the x value, plus c. There we go, so negative 3 over 2, let's do this on the calculator again, multiply that by 5, and you get minus 15 over 2, or minus 7.5. So we have minus 5 is equal to minus 7.5 plus c, and if we add that 7.5 over to the negative 5, we get 2.5, so 2.5 equals c. And again, we just need to plug that value back into our equation of the line, which we've got just up there. There we are, and if we plug that in, and again we can write it as a decimal, we'll get y equals minus 1.5x plus 2.5. There we go, and that will finish off that question for us. There we go, so we had the same gradient on both, but different line equations for each one, and obviously different original equations there to actually find those gradients. But in both cases, our gradient of the line given to us was 2/3. Both had a negative reciprocal of negative 3 over 2. And then obviously we've got both our line equations in a similar fashion. But again, with this line equation in the second question, you could have written those as fractions again. You could have had y equals negative 3 over 2x plus, and then that would have been 5 over 2 for the 2.5 there. But there we go, there are some of our starting line equations that we're going to have a look at with perpendicular lines. Now we're going to have a look at one more type of question here before we have a look at our exam questions. Okay, so this question here, there's a little bit more words, and we've got a little different way of writing our answer in this one. So it says the points P and Q have coordinates 5, 3 and 11 minus 1. Find the equation of the line perpendicular to PQ and passes through the midpoint. Give your answer in the form, and here's where we're going to write our answer differently. AX plus BY plus C equals 0, where A, B and C are integers or whole numbers. So let's have a look at this. Now, for starters, we've got to find the equation of a line perpendicular to one that passes through these 2 points. So if it's perpendicular, it's obviously going to have a gradient that's well, a negative reciprocal for its gradient. So in order to do that, in order to find that, we're going to have to find the gradient between these 2 points, okay, between P and Q. So if we actually go about doing that, we just need to do our change in y over change in x, and that's going to allow us to find the gradient. Now the change in y goes from 3 to minus 1, and that is a change of minus 4. So minus 4 is going to be our change in y, and our change in x goes from 5 to 11. So from 5 to 11 is 6. So we have negative 4 over 6, and if we simplify that, that's negative 2/3. So the gradient of the line PQ is negative 2/3. Now we're obviously looking at the perpendicular line, so our perpendicular gradient, the negative reciprocal of that is going to be positive 3 over 2. So there we go, there is the gradient we're going to be using for our line 3 over 2. Now obviously this then says that it passes through the midpoint. Okay, so if it passes through the midpoint of PQ, we actually need to know what that coordinate is, otherwise we've got nothing to put into y equals mx plus c. So we need to find the midpoint of those 2 coordinates, and that's easy enough for us to do. If we want to find a midpoint, we can just add the coordinates together and divide it by 2, essentially finding the mean of those 2 coordinates. So if we have a look, 5 and 11 as our x coordinate, if we add them together, that's going to be 16. So for our midpoint, and let's write this out in full here. So the midpoint, we're going to have 5 plus 11 divided by 2 for the x coordinate. And for the y coordinate, we're going to have 3. Let's have a look, add the minus 1. So 3 plus minus 1 all over 2. And that's going to give us our midpoint there. Now 5 plus 11 is 16. If we divide that by 2, we get 8. 3 add negative 1 is positive 2. And divide that by 2 is 1. So there we go, there's our midpoint, 8, 1. So the extra step there of obviously finding the midpoint, although nice and easy, add together the 2 coordinates and halve it to find the mean. So we've got all our pieces now. We've got the gradient, which is 3 over 2, and we have our midpoint coordinate, which is 8, 1. Now we just need to put it into y equals mx plus c like before. So we have y equals 3 over 2x plus c, and then we'll put this coordinate in. So y is 1, so 1 equals 3 over 2 multiplied by the 8 plus c, and 3 over 2 times 8 is 1.5 times 8, so that's 12. So we have 1 equals 12 plus c, and again you can just check that on the calculator. take away 12 from both sides, and we get c equals negative 11. There we go. So c equals minus 11 for that question. And obviously you have got your calculator, so do just check all those little sums as you're going along. Obviously your 12, 1 take away 12, it's a nice and relatively easy sum for you to do there. But obviously don't forget you do have your calculator if you need to check any of these. Right, so putting all these pieces together, we're going to put the minus 11 back in place of c, which is up there. And if we put that in, we get y equals 3 over 2 x minus 11. Now that is the equation of the line, but it wants your answer in the form ax plus by plus c equals 0, and it says it wants them where a, b and c are integers. Now in order to make sure that that x coefficient there is a whole number, we're going to have to remove the denominator of the fraction, and at the moment it's being divided by 2. So we're going to want to times everything by 2 here. So if we times everything by 2, we get 2y equals, and that's just going to be 3x when we remove the divide by 2, and that's going to be minus 22. And then in the final step here, it wants us to make sure it's all equal to 0, so we're going to want to move everything to that left hand side there. So we're going to want to minus, and to be fair we could actually move everything to the right hand side as well, that would be absolutely fine for us to do, but if we move everything to the left, look, we're going to have minus 3x at the start when we get rid of that 3x, so minus 3x plus the 2y, add that 22 over, so that's plus 22, and that all equals 0. There we go, and there's our final answer written in the form that we wanted. A is negative 3, B is positive 2, and C is positive 22. Again, just making sure that you're careful with those steps. From there to there, I did 2 steps there. I minus 3x from both sides, and I added the 22 to both sides to make sure it equals 0. Although to be fair, we could have actually moved everything to the right hand side. We could have had 3x minus 2y minus 22. Okay, so we could have actually done that as well if we wanted to just move the pieces to the right. But there we go, there is our answer for that question, and here's one for you to have a go at. Okay, so here's your question, very similar to the last one that we looked at. You've got 2 points P and Q. It wants you to find the perpendicular line that passes through the midpoint, and again writing it in the form which I'll highlight here, ax plus by plus c equals 0, where a, b and c are integers. So pause the video there, have a go at this question, and we'll go over the answers in a sec. Okay, so to start this question off then, we're going to do our change in y over change in x. So looking at our change in y, that's going to give us a value from 6 to 0, and that is a value of negative 6. So here we go, minus 6 is our change in y, and our change in x is going to be from negative 1 to 9. And from negative 1 to 9 is a value of 10. And again, we can simplify that, that's going to become negative 3/5. There we go. So for our perpendicular gradient, our negative reciprocal of negative 3/5 is going to be positive 5 over 3, or positive 5/3. So there's the gradient that we're going to be using for our line, 5/3. Now we just need to find the value of the midpoint again, and if we label this up, we'll have a look at the midpoint, and that is going to be adding together the x coordinates to start with. So negative 1 add 9 is 8, so it's going to be 8, and we're going to divide that by 2. And for the y coordinate from 6 to 0, if we add them together, that's 6. And then again, if we halve that, so that's going to give us our y coordinate. So that gives us a value of 4 for our x coordinate, 8 divided by 2, and 6 divided by 2 is 3. So there's the midpoint that it has to pass through, 4, 3. So there we go, we can put that into our line equation. So we're going to have y equals 5/3, our perpendicular gradient there, x plus c. And then we're going to put in our midpoint. So our midpoint is 4, 3, so our y value there is 3. So we have 3 equals, we have 5/3 multiplied by the x coordinate there, which is 4, and then we're going to add c. Okay, so we need to do 5/3 times 4. And again, you can use this as fractions. You can just do 20 over 3, getting your numerator there, but I'm just going to do it on the calculator, 5/3 and times it by 4. And again, it gives us 20 over 3, or 6.6 recurring. So let's have a look. We've got 3 equals, and then we've got 20 over 3 plus c, and we need to minus 20 over 3 from both sides. So if we do 3, take away 20 over 3, and that gives us negative 11 over 3. So we get c equals negative 11 over 3. And in this circumstance, I definitely wouldn't be writing that as a decimal, because it's just easier for us on the next step now to leave it as minus 11 over 3. So if we put this into our line equation, let's have a look at what we get. We get y equals 5/3 x minus 11 over 3. Now obviously it wants it in a particular form, and it doesn't want us to have any fractions there. So as we've got a 3 as our denominator, we're going to times everything by 3. And if we times everything by 3, we get 3y equals, that 5/3 just turns into 5, so we get 5x, and our 11/3 just turns into 11, so minus 11. There we go, and we're almost done. It just wants everything on the left hand side there. So again, if we move everything over to the left, we're going to get minus 5x at the start when we minus that over, so minus 5x. We've got the plus 3y, and then we're going to add the 11 over, so plus 11, and that is all equal to 0. And there we go, there's our final answer written in the form that it wanted there, ax plus by plus c equals 0. So a is -5, b is +3, and c is +11. So there we go, that is obviously the end of our little questions there, just looking at some of the fundamental skills here. In all of these questions though, we are looking for the gradient, which we can then obviously flip over with our negative reciprocal for our perpendicular gradient, and obviously always using y equals mx plus c then just to sub in any coordinates on that line. And in these cases here, we were looking at passing through the midpoint. So what we're going to have a look at now is some of our exam style questions where we have some visuals alongside our question. I'm going to kick off that with our first question here. Okay, so we're going to move on to our exam style questions. Now with all of these type of questions, they're all a little bit different. They've all got sort of similarities, but each question is unique in its own way. So we're going to have a look at a few different ones. Now it's completely up to you throughout these, whether you just pause the video and have a go, or have a go at particular parts. But we're just going to talk through 4 questions. One of them I am definitely going to get you to just have a go at. But for the purpose of these questions here, you might just want to pause the video, have a go at as much as you can, and then have a think about sort of where you sort of got stuck, and obviously watch as we sort of talk through each particular question. We're going to start with this one anyway, and it says here we've got 3 parts, and we've got some information that's obviously given to us visually on the right there. So it says the points L and M have these 2 coordinates, and that's given to us on the diagram as well. We've got L is -1, 2, and M is 7, -4. Now for part A, it says find an equation for the straight line passing through the points L and M, and give your answer in the form ax plus by plus c equals 0. And I'm just going to highlight that because we don't want to forget to finish that bit off at the end there. So obviously we've not got anything about perpendicular lines or anything like that in part A. It just wants us to find the equation of the line L to M. So that should be easy enough. We just need to get the gradient and obviously sub one of those coordinates in. Now the gradient there is obviously changing y over changing x, and it goes, and if we start with the L and move to the M, it goes from 2 to -4. So that gradient there for changing y is going to be from 2 to -4 is -6. So we get -6 there. And our change in x goes from -1 to 7, which is +8, so it's -6 over 8. And if we simplify that, we get -3 over 4, just dividing the top and bottom by 2. So -3/4 is our gradient. Now if we sub that into our equation of a line, we get y equals -3/4 x plus c. There we go, and we can use that now to get our value of c. So it doesn't matter which coordinate we use, I'm just going to use the coordinate L. And if I put that coordinate in, we get 2 equals +3/4 there when we times that by -1. So 3/4 plus c, and then we'll get our value of c there. If we subtract 3/4 from both sides, we're going to get c equals 1 1/4, which I'm going to leave in terms of quarters, so I'm going to write that as 5/4, and not forgetting as well, you've got your calculator, so you can always do this with your calculator. Now if we put all those pieces into place, we get y equals, our gradient was -3/4, so y equals -3/4 x, plus our c value there, which is 5/4. There we go. Now obviously we've got a denominator of 4 there, so in order to get this having integers in front of all the pieces, we're going to multiply by 4. So if we times everything by 4, we get 4y equals -3x plus 5. And then again, we've just got one more step. We just need to move everything to the left so that it equals 0, and sticking the x piece at the front there. So if we do that, we get 3x plus 4y minus 5, and that equals 0. And obviously again, you could move those pieces to the right hand side and you'd have the different signs in front of the pieces there, but obviously it doesn't actually matter either way, so I'm just going to move them to the left and leave it in that form. So there we go, there is part A. We've got the equation of the line, 3x plus 4y minus 5 equals 0. And let's have a look at part B. So let's get rid of some of this working out here. Okay, now part B is looking at a different line here. It's looking at the point N, and the point N is on the line M to N. So it says there, given the coordinates of N are 16p, which are given to us on the diagram, where p is a constant, and the angle LMN is 90 degrees, find the value of the constant p. Now obviously that 90 degrees is also given to us on the diagram, and it's essentially just telling us that the line MN is perpendicular to the line LM. Okay, so if we have a look at this, we already know the gradient of the line LM, that's a gradient of -3/4. So our perpendicular gradient for this question, which I'm going to write up here, is going to be +4/3. So there we go, that's going to be the gradient of that line. So if we put that into y equals mx plus c, so we've got y equals 4/3 x plus c. If we can get the equation of that line, we should be able to find the y coordinate at n, because we can just make sure that we can balance our equation using that value of x. So let's have a go at finding our equation of the line here. Now we've got one coordinate on that line at the moment, and that's the coordinate for m. So if we put that in, we can get the equation of that line. So we have -4 as our value of y, which is equal to 4/3 multiplied by 7 plus the c. So 4/3 times 7 is going to be 28/3, and if we take away that 28/3 from -4, so -4 minus 28/3, we get a value of -40/3. So we have c equals -40/3, and then we can write the equation of our line. So y is going to equal the 4/3 x minus 40/3. There we go. So there's the equation of the line m to n, and it wants us obviously to find the y coordinate, or the value of p. So if we have a look at using this equation, then let's get rid of some of this working out. We've got our equation, we actually just need to use it. So let's move this up next to our line, and let's sub in that coordinate. So we've got the x coordinate, which is 16, and we've got an equation here that tells us how to find the y coordinate. Y is equal to 4/3 x minus 40/3. So that y coordinate is going to equal 4/3 multiplied by 16, and then we just need to take away 40/3. And if we type that straight into the calculator, we've got 4/3 multiplied by 16, and then we're going to take away 40/3, and that gives us a y coordinate here of 8. So y equals 8. Okay, or in other words, p equals 8. So we'll write that down over here. We've got p equals 8. There we go, and there is our part B. Okay, there we go. So nothing really too different from what we've looked at, other than that obviously we've just had to sub a coordinate in to find our other coordinate in that particular question. Now for part C, for the end of this, it says, given that there is a point K, such that L, M, N and K form a rectangle, find the coordinates of K. That's a bit of a logical question really, because if we look at this diagram, in order to form a rectangle, we would need a point around about there, if I try and draw it in as best as I can. So if I get rid of that, it was around about here, and that would form a rectangle for us. So all we're really wanting to do is find out where that coordinate is, and we can do this using a bit of a pattern or a bit of logic. Now from L to M would have to be the same pattern as from M to N. So how do we get from M to N? Now in terms of moving right and moving up, what would that distance be? So from 7, the x coordinate of M, over to 16, that is a distance of 9. So that's going to cross 9. Up from -4 to p, and we know that p is 8 now. That's gone up from -4 to 8, so that is a distance of 12. So it's gone 9 to the right from 7 to 16, and it's gone 12 up from -4 to 8. And we can do that exact same pattern from L. If we go 9 across, that would give us an x coordinate over here. From -1, that would move over to 8. And if we move 12 up, that would go from 12 up to 14. So we would have 8, 14 as our coordinate. So again, just using a little bit of logic there to actually find these two numbers, and thinking about the logic behind that and how we would actually get there. So 8, 14 is our final answer. And there we go, we can lock that off as our final part of that question. But again, just thinking about the fact you could have actually gone for a pattern in a different way. You could have had a look at the pattern from M to L, moving left and up that way, and done the same from N to K this way, left and up. Okay, so you're not obviously having to do it exactly the same way that I've done it, but there are different ways that you could have looked at that. But that was just quite a logical question there in part C to finish that off. So there we go, that's our first question. Let's have a look at our next one. Okay, so for this next question, and again, these all look very similar. We have obviously a graph on the right there, and we've got two lines, and I'm going to assume just by looking at it, although I'm guessing it's going to tell us this, that one of these lines is perpendicular. So it says in the question here, look, the line L1 has equation 5y equals 4x plus 10, and it says the point P with x coordinate 5 lies on L1, and the straight line L2 is perpendicular to L1 and passes through P. There we go, so we're told there it's perpendicular. Obviously we can never make any assumptions that it's perpendicular, but generally speaking these questions are always going to mention that they are perpendicular if they look so, but always do make sure that you read the words and make sure. So it says here, obviously we've got the equation of L1, which is our line here, and then it gives us that there 5y equals 4x plus 10, and it says the point P, which is given to us on the diagram here, has an x coordinate of 5. So there we go, we can write this in here. We've got 5 and something we don't know just yet, but I'm guessing we're going to figure that out, so let's leave that open, ready to figure out. And then we've got the straight line L2, which is perpendicular and passes through P. So it says find an equation for L2 and write your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So again, we've got the equation of L1. So if we have a look at this equation here, and again, we want it in the form y equals mx plus c, so we can have a look at its gradient. So if we divide everything by 5, that's going to make it y equals, and we'll get y equals 4 divided by 5, so 4/5 x plus, and 10 divided by 5 is 2. So there we go, we've got the gradient of the line there. The gradient of the line L1 is 4/5, and we want to have a look at the line L2. So if we find our perpendicular gradient there, so the perpendicular gradient, if we do our negative reciprocal, is going to be -5/4. So there we go, we've got the gradient of the line, and we also have one of the x coordinates. Let's just have a think though, because we do not have all of our information here yet, perhaps to go about working out this answer. So what can we do? We can write our equation of L2 with our new gradient and see where we can go from there. So we've got y equals -4/5 x plus c. Right, so thinking about this then, where can we go from here? Because at the moment we don't actually have any coordinates, okay? So what can we actually figure out? Now if we first look at this question, we've obviously only got a partial coordinate at point P. However, that point P does lie on the line L1. So we can actually go ahead and find the y coordinate straight away using our equation for the line L1. As we've already figured out here, look, that y is equal to 4/5 x plus 2. Now if the x coordinate is 5, we can just sub that in. So y is going to equal 4/5 multiplied by the 5, and then we're going to add the 2. And if we type that in on the calculator, 4/5 times 5 is 20/5, which is 4, and then we're going to add 2 to that, so y will equal 6. So there we go, straight away we can get our y coordinates. We've got 5, 6, and now this makes this problem a little easier for us to approach, because we can put that coordinate, which is also on line L2, into our line equation that we've just written here. So if we sub those coordinates in, we get 6 is going to be equal to -5/4 multiplied by the x coordinate there, which is 5, and then we're going to add c. So -5/4 multiplied by the 5 is going to be -25/4. So if we write that in, we've got 6 equals -25/4 plus c, and we can add 25/4 over to our other side there to get our value of c, and if we add that over we get 49/4, just doing that on the calculator, and 49/4 is 12 1/4, but I'm just going to leave that as 49/4, so c is equal to 49/4, and then again, just like before, all we need to do is plug that into our line equation here, and again we'll write it in the form that they're asking for. So if we write that in there, we get y equals -5/4 x plus the 49/4 value of c that we've just worked out. And obviously it wants it in that form there, like our previous questions, ax plus by plus c equals 0. So we're going to want to obviously eliminate these denominators by timesing everything by 4. So times everything by 4, and we get 4y equals negative 5x plus 49. And again, we just want to move everything over to the left. So if we add 5x over, we get 5x plus the 4y, and then minus the 49, and that all equals 0. And there we go, there's the equation of our line. So there's part A, we've got the equation of our line in the form that they're asking for. Let's have a look at part B. So it says in part B, calculate the area of the triangle SPT. So SPT is that triangle just there. Now, one of the pieces of information we need for working out the area of a triangle we already have, and that is the height. Okay, we know the height because the y coordinate of point P is 6. So we know the height of the triangle there is 6. All we need to work out is the length of the base, and then we can do half base times height. Now, if we have a think about this, we just need to think about the coordinates that we're looking for. So if we get rid of some of this information here, or this working out, we can have a look at those two coordinates. Now, if we need to figure them out, we have the equations of both of their lines. Okay, we know that the equation of line 1 is up there, y equals 4x plus 4/5 x plus 2. And the equation of the second line we've worked out, y equals negative 5 over 4x plus 49 over 4. Now, in order to get these 2 points down here, so the x coordinate of S and the x coordinate of T, we can have a look at the y coordinate, which is 0. Okay, any coordinate on the x-axis, the y coordinate there is 0. So if we take our two equations and we set y equal to 0, we'll be able to work out the x coordinate. So if we take our first one, which is our 4/5 x plus 2 for line L1, we can say, okay, well, when does that equal 0? So y is 0, so 0 equals 4/5 x plus 2. So we're going to minus 2 over to the other side, and then we're going to divide by 4/5. That's going to allow us to find the x coordinate. So we have minus 2 equals 4/5 x. And if we divide both sides by 4/5, again, I'm just doing this on the calculator, we get x is equal to negative 2.5. Or in other words, the x coordinate is minus 2.5. That gives us part of the distance there. That tells us that this distance over to 0 is a distance of 2.5. Now we just need to find this one. So if we do exactly the same process with the other line, so we'll set y equals to 0, we get 0 equals, and this time we have minus 5/4 x plus 49 over 4. What I'm going to do is I'm going to add the 5/4 x over to the other side. Again, you could just minus the 49 over 4, but to avoid having those double negatives there, I'm just going to add the 5/4 x over. So we get 5/4 x equals the 49 over 4. And again, I'm just going to divide now by 5/4. 49 over 4 divided by the 5/4 gives us an x coordinate of 9.8. There we go, so we get 9.8 as our x coordinate there. So that tells us that distance there is 9.8, and then we can combine that together to get our total distance there along the bottom of the triangle. So again, just a little technique there that's quite important. If you're trying to find an x-intercept, which we found here at S and T, you can just set y equal to 0 because we know the y coordinate there. From there, it's just solving a linear equation. So we've got our distance, we've got 2.5 and 9.8. So if we get rid of some of this working out, let's have a look at that as a total distance. So if we add those together, 2.5 plus 9.8, we get 12.3. So the length of our base is 12.3. And we want to times that by the height, which is 6, and then either times that by a half or divide it all by 2. But there we go, we've got base times height divided by 2. And if we type that into the calculator, we get a total area there of 36.9. And we don't have any units, so we could just say units squared. But the area of the triangle there is 36.9 units squared, whatever they are. So there we go, 36.9 is our final answer. And that's part B. And that's really finishing an accumulation of all the kind of things that we could be asked for in these types of questions, looking at coordinate geometry where we have these visuals here. So there we go, that's our second one. Now I've got one for you to have a go at. It's got different elements to what we've looked at, but as I've said before, all exam questions that you see are going to have a slightly different element, so it is important to make sure that you have a little practice on something that's a little bit different. So here we go, here's a question for you to have a go at. Okay, so this question here, again, it does have some sort of differences within this, but let's just have a little read through it before you pause and have a go. It says we've got a straight line L1 and it gives us the equation for that. There we go, so that is our L1 equation, and that is this line just here. Now it then goes on to say that the straight line L2, which we've got just here, is perpendicular to that. So that line's perpendicular, and it says it passes through the origin, or in other words, it passes through the coordinate 0, 0. Okay. It then says find the equation for the line L2, and then we've got a part B. So part B, it says find the line L2 intersects the line L1 at point C and crosses the y-axis at point B, which is shown to us on the diagram. It says find the area of the triangle OBC and give your answer in the form A over B, where A and B are integers to be determined, and we'll have a look at that bit towards the end. Okay, I think that bit's going to come out quite nice and easy for us though. But OBC is this triangle here. So just thinking about the logic behind this question, if we look at this being the base this time, we need to find that distance there. Or in other words, where does the line L1 cross through the y-axis? We then also need to try and find the height of that triangle, which in this case, if I look at it in that orientation, is that distance there. Or in other words, the x coordinate at point C. So they're the things that we need to find. Then we can just do half base times height, but that is the sort of idea behind this question. So pause the video there, have a go, see what you can find, and we'll go over the answer in a sec. Okay, so looking at this question then. Now, first thing that jumps out is the fact that this equation here is not in the form that we want it. So if we move that 2x to the other side, and then we can divide by 3 to make it y equals, we end up with 3y equals negative 2x plus 26. And if we divide that by 3, we get y equals minus 2/3 x plus 26 over 3. Just trying to think if that simplifies. No, it doesn't, so that would be just plus 26 over 3. Okay, right, now that 26 over 3 there is our y-intercept of line 1. So really we've already got the height here. The height of that triangle, or the base in whichever way we're looking at it, is 26 over 3. So that right there gives you a little hint as to why in part B the area is going to be in the form A over B, because we've got a fractional height there, or a fractional base depending on which way we look at it. But we've got half of our information there for part B. Obviously we're looking at working out a line equation for L2 though, so we're going to look at that to start with. So it says obviously we want to get the equation of L2. Now L2 is perpendicular. So the gradient that we've got at the moment is negative 2/3. So our perpendicular gradient for that, or MP, is going to be positive 3 over 2. Now all we need to do is sub that into our equation and have a look at a coordinate that it goes through. Now there's none given to us on the diagram, but it did say it passes through the origin. So our coordinate just there is going to be 0, 0. So if we put this into our line equation, we get y equals 3 over 2 x plus c. Now as both are 0, if we sub 0 and 0 in, which we don't really need to do if we understand our line equations here, but if we do sub 0 and 0 in, we get 0 equals 3 over 2 times 0, which is 0, plus c, so c equals 0, and that would make sense as our y-intercept is 0. Or in other words, we can basically just get rid of that plus c. So the equation of that line is going to be y equals 3 over 2 x. There we are. So something a little bit different there, obviously, where our y-intercept is 0. But there we go, that is part A. We have our equation of the line L2. It's y equals 3 over 2x. Moving on to part B then, now we have that equation, we're going to have a look at finding the area of the triangle. Now we've already got the base there, 26 over 3. We just need to find the height, or in other words, we need to find the coordinates of C. Now if we have a think about this, what process can we use to find the coordinate of C? We could potentially think about using some simultaneous equations or something like that, or is there another way that we can actually find this? Now I think the easiest way for us to do this is to apply some of that intersecting lines and having a look at the equation in that sense. So if we set these two equations equal to each other, we could actually go about just solving it that way. So we've got our first equation there, y equals negative 2/3 x plus 26 over 3, and we have our second equation, y equals 3 over 2x. Now, if we set them equal to each other, as they're both equal to y, we should actually just be able to solve this as it is. So if we take our first equation, which is minus 2 over 3x plus 26 over 3, and we set that equal to our other equation, which is 3 over 2x, and then we should be able to just go about solving that. Now again, this is obviously linked into simultaneous equations here, where we have two equations to solve, and again obviously I'll make sure that those videos are linked in the description if that sort of has passed you by there. But there we go, we can actually use that to solve to find our value of x at that coordinate. So if we get all our x's on one side, we need to add 2/3 x to the other side, and the nice thing here, obviously we can use a calculator for that. So if we do 3 over 2 and we just add 2/3 to that, we end up with 13 over 6. So we have 26 over 3 is equal to 13 over 6 x. There we go. And from there we can divide by 13 over 6, and that's going to give us our value of x. So if we do 26 over 3 divided by the 13 over 6 there, we get x is equal to 4. Now, as we are looking for the area of the triangle, bearing in mind the concept here that we only really need to know the x coordinate, because the x coordinate down here being 4, that's not the straightest of lines there, might want to try that again, as the x coordinate down there we go, is 4. That tells us there the height of our triangle, obviously if we orientate it the other way around, so the height there being 4. Now obviously using that process, we can now just plug that all into the area of a triangle formula, so half base times height, and we'll have our answer. But again, just thinking about this process that we've just done, and thinking about obviously the idea of using a simultaneous equation to solve that. Okay, so if we get rid of all of this, and we can plug in all of these numbers, so we get our base, which is 26 over 3, we can times that by the height, which is 4, and we can times that by a half, okay, or just divide it all by 2. And if we type all of that into the calculator, we get 52 over 3. There we go, it's an area, so that'd be units squared, but we have 52 over 3, and that is in the form that the question was asking for there, where it said find the area of that triangle and giving it in the form a over b, where a and b are integers to be determined, so a is 52 and b is 3. There we go, so another little process that's come into a question there, and as I said, obviously all these little questions have little differences and little sort of processes that can come up, but the one that's come up in this question here of using simultaneous equations to find an intersection point between two lines is obviously quite a common one, and one that's come up from GCSE as well. So do make sure, and again if you were stuck on that little bit, I will link all the videos in the description for simultaneous equations, but let's have a look at our final question then to finish off this topic. Okay, and for our final question, we have got a bit of an accumulation of everything that we've looked at. So for this particular question here, I would encourage you to sort of have a go at this one, so you might just want to pause the video, have a read and see how far you can get, but we're just going to have a little look and talk through this question. So it says in the first bit of the words here, we've got the point P is 0, 2, and that's not given to us on the diagram, so I'm just going to label that on there, 0, 2. And then have a look at our next bit. We've got point Q, which is 3, 7. Again, not given to us on the diagram, so let's label that 3 and 7. And it says that they lie on L1. It says that line L2 is perpendicular and passes through Q and crosses the x-axis at point R. Find an equation for L2, giving your answer in the form. And again, we've got ax plus by plus c equals 0. So if we have a look, we can actually get the gradient. We could actually get the equation of line 1, but we can get the gradient of line L1. We can then use that to get our perpendicular gradient for L2. And obviously it passes through point Q, so we have a coordinate already that's on that line, 3, 7. So if we have a look, going for our change in y over change in x, I'm going to go from point P to point Q. So from 2 to 7 is 5. There we go. And from 0 to 3 is 3. So our gradient is 5/3. Now having a look at our line L2, we need our perpendicular gradient. So if we flip that over and change the sign, we get minus 3/5. So there's the gradient of line L2. Now we know that passes through the point 3, 7, so the rest of this process should be relatively familiar now. So if we put this all in, we get y equals minus 3/5 x plus c. And we're going to put the coordinate 3, 7 in. So 7 equals minus 3/5 multiplied by the 3 plus c. Now, negative 3 to 3/5 times 3 is negative 9/5, and we're going to add that over to the 7. So I'm going to skip a step here. I'm just going to do 7 plus 9/5, and that gives us 44 over 5. Or in other words, c is 44 over 5, and then we can write our equation, which is going to be y equals the minus 3/5 x plus the 44 over 5. There we go. So there's the equation of line L2. Obviously it wants it in that format again, so we're going to need to multiply everything by 5 in order to get there. So if we times everything by 5, and I'm going to write it up here, there we go, so times 5, and we get 5y, and that's going to equal minus 3x, and then plus 44. And then rearranging that to equal 0, if we add the 3x to the other side, we get 3x, add the 5y, minus the 44 when we move that over, and that is equal to 0. There we go, so there is our equation for line L2. So there's part A done. Part B then says find the exact coordinates of R. Now we've mentioned this in a previous question. Look, the coordinate R is lying on the x-axis, and we know on the x-axis there the y coordinate is 0. So obviously we can use the equation here, and this is the one that I would encourage you to use here, just setting the y coordinate equal to 0. So if we get rid of some of this other working out, but we'll keep that one there as we're going to use that, and we just set the y coordinate equal to 0, we can just solve that to find x. So let's have a look at that. Let's get rid of that 5. So if we say when y equals 0, that's going to be equal to negative 3/5 x plus 44 over 5. If we add the 3/5 x to the other side, we get 3/5 x equals 44 over 5, and then we can just divide by 3/5 there to get our value. So if we divide by 3/5, we get our value of x, and we get x is equal to, and again just doing this on the calculator, we get 44 over 3. There we go. So there is our x coordinate, and obviously we know that the y coordinate is 0. So the exact coordinates of R, we're going to have 44 over 3 and 0. There we go, and there is our coordinate, and let's just highlight that, there we go, just to indicate our final answer there, 44, 3 and 0. Okay, so moving on to part C, it says find the exact area of the quadrilateral ORQP where O is the origin. So let's have a look. ORQP goes O to R to Q to P and then back down to O there. So we've got that quadrilateral there. Now to be fair, there's a couple of little bits that we could do in order to find this, but in essence we have one big triangle, and if we just get rid of this for a sec, let's just highlight this big triangle. We've got the big triangle here, which is a right angled triangle there going up the axes, and we have a smaller triangle just here that we don't want included in that area. And we've had a look at working out some of these triangles, but essentially if we get the big triangle and take away the little triangle, that's going to give us the area of what's left over, that quadrilateral. So if we get rid of some of this, let's get rid of some of this working out here. There we go, and let's just have a look at working out some of these areas. Now the big triangle, okay, which again I'm going to highlight, so we're going to work out the area of this big triangle. Let's have a look. What do we get as the area of that? Well, the base goes from 0 over to 44 over 3. So it has a base length of 44 over 3. And let's just label this as the big triangle. There we go. So we have 44 over 3, which is the base. We're going to times that by the height, which at the moment we actually don't know, but we can find the height because we know the equation of the line L2. Okay, we've already looked at the equation of the line L2, and in fact in this form just here, we actually have the y-intercept just there, 44 over 5. So we should probably label that, let's label that as 44 over 5. There we go. There's the height of the triangle. So we're going to times that by 44 over 5. And we need to halve that, or times it by a half. So if we times that by a half there, and if we just do all that on the calculator, we don't get the nicest numbers. We get a decimal here. We get 64.53, and the 3 there is recurring, so 64.53 recurring. So there is the area of our big triangle. Now we just need to have a look at the small triangle. So if we get rid of this, and let's have a think about this last little triangle we're looking at. So we're looking at this one now that we want to take away, just to get the area of what's left over. Now for that particular one there, we actually have all the lengths that we need. From the axes over to point Q there, we know that point Q has an x coordinate of 3 given to us just here, so the height of that triangle is 3. And we can get the base here because that goes from the point 2 on the y-axis there up to 44 over 5. So if we just work out that difference there, 44 over 5, take away the 2, gives us a length there of 34 over 5. So that length is 34 over 5, and the height is 3. So for the small triangle, we have our base, which is 34 over 5. We have our height, which is that little distance 3, and we're going to then times that by a half or divide it all by 2. But if we just type that straight into the calculator, we get 10.2 as the area of the small triangle. Now obviously the whole concept of the question here is to work out the area of the quadrilateral. So in order to work that out, we're going to take the big triangle, subtract the little triangle, and it's just going to give us the area of that bit there, or in other words, what's left over. So we want to do 64.53, that larger triangle there. Let's just get rid of this so we have some space. 64.53 recurring, and take away the 10.2, and it leaves us with a decimal which is 54.3 recurring, or if we turn that into a fraction, which it does on our calculator, we get the answer 163 over 3, and again that would be units squared, but there's our final answer, 163 over 3. So there's 3 parts to this question. We had our equation of the line in the format that I'd asked for down there. We also had the coordinates of point R, which we got up here, and then we got our final bit down here, 163 over 3 as our area. And again, just thinking about that in a slightly different way there, we had the larger triangle subtracting the smaller triangle to find out what was left over. But there we go, that's our final question. A nice little selection of exam questions there. Hopefully that's been nice and helpful for you. Again, do not forget that I'm putting all of the coordinate geometry stuff from GCSE in the description to make sure that you go over all of those if you're unsure on any of this. But there we go, there's a nice little selection of exam questions. So hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.